In this lesson, we will talk about ports in an electrical circuit. Any electrical circuit has at least one port. A port is a combination of two terminals of the circuit. In this example, I represented a simple voltage divider powered by a voltage source, like a battery, for example. The divider's output is then connected to RL, which is the load of the circuit. This can be seen as just one big circuit, but it can also be thought as made of different blocks that talk to each other. And blocks talk to each other via ports. In this example, I added some white circle to individuate ports and to divide the schematic in three different blocks. Here are the circles that I used to indicate terminals. The first block contains the battery. A battery does not have any input. It is the source of energy for the circuit, so it only has one port. We could call it output port. This is the port. The second block is the voltage divider. This block has an input port, where the voltage of the battery is applied, and an output port, which is indicated by two terminals across R2. Finally, the last block is the load, which really only contains the resistor RL. This block also has only a single port. I want to highlight a few more things. A port is always defined by two terminals. The reason for this is that you need 2 points to define a voltage, and currents always need to have a return path. If you look at this port, for example, the one of the battery, the Kirchhoff current law tells us that the current injected by the battery into the voltage divider must return from the other terminal. So if we call this one IB, we must have an IB coming back on the other terminal. Hence, a block without a second terminal will make no physical sense. Sometimes you will see blocks represented with one terminal only, but that is simply due to graphical simplification that assumes that the second terminal is either hidden or it is ground. Ports are also not fixed for a given circuit. You can literally define a port between any two nodes of the circuit if you like. In this example, one additional port could be the one whose terminals are around the resistor R1. So we could define this. This could be another port. However, in this case, the voltage on R1 does not seem to be used by the circuit. The load, in fact, is connected on R2. So defining this port will be at least curious, but there's nothing wrong with it. Splitting circuits in block and defining ports is an arbitrary process. One could have chosen to consider the battery and the voltage divider as one big block, having only one output port, like this. Just one block with an output port. One could even consider the whole circuit as a block with one output. The opposite extreme of this example would be if each of the components become its own block, but that is a rather pointless case, as you might as well look at the schematic at that point. The goal of dividing a circuit in blocks is to make it simpler to study, but where the line between one block and another is drawn is arbitrary and changes from person to person. For example, on the same project, the circuit designer will need to look at the detail of the schematic, while a system architect, who is looking at the design from a higher point of view, would prefer to study a block diagram to hide the details and focus on the bigger picture.